Hey everybody, this is Mr. Hutchinson. This is my first recorded video lesson. Uh, all of the information that I'm going to be talking about this evening can be found on page 11 in your SRB, and you want to really be focusing on this middle section right here. So let's get started with our first divisibility rule. The divisibility rule for 2. So first, let me say that all numbers are divisible by 1. So I'm really not going to spend any time showing you that one. But I will spend some time looking at the divisibility rule for 2. So the first thing you want to know that if a digit or a number ends with 2, 4, 6, or 8, that number is divisible by 2. Now, as you notice, all of these are even. Oops. Even numbers. Sorry for this. So for example, let's look at the example of 246. The first thing I notice is that this number has the 6 in the ones place, and that 6 is an even number. If the last digit, which is in the ones place, is an even number, either 2, 4, 6, or 8, that whole number is divisible by 2. Ching! Try this number below. So I'm going to give you the number 524. Take a moment, try to figure out if 524 is divisible by 2. I'll wait. Okay, enough of that. Okay, the first thing you probably should have been looking at was the number in the ones place. If you notice that number is either 2, 4, 6, or 8, or an even number, you know that entire number is divisible by 2. So this number, if you said yes, then you are correct. If you want an additional practice, there's a few additional ones at the end of the SRB page at the bottom of page 11. The divisibility rule for number 3. Let's use the number 237. 237. I think the best way to explain this divisibility rule is actually to model it out for you. If you take that number and break it down into 2 plus 3 plus 7, and if you add up all of those digits and you come up with a number that is divisible by 3, then that number is divisible, the whole number is divisible by 3. So for example, 2 plus 3 is 5. 5 plus 7 equals 12. You want to look at this number here. If you know any factors, and I like to use the factor triangle, if you take the number 12, put it into the factor triangle, and you know that we're looking at the divisibility rule for 3, you have to ask yourself, do I know anything that I can multiply 3 by to equal the number 12? In this case, we know that the number is 4, so the number 237 is divisible by 3. So the answer for this one would be yes. Why don't you try one on your own? So we'll look at the number 526. Once again, you want to break this number apart so that you can find the sum of all of the digits. You'll know that it's 5 plus 2 plus 6. You'll come to realize 5 plus 2 equals 7. 7 plus 6 equals 13. You put that in the factor triangle. 13 is the total number. 3, once again, is the number that we are, one of the factors that is known. If we're trying to figure out is it 13 is divisible by 3, then you have to ask yourself, do you know of any number that you can multiply 3 by to get 13? The answer to that is there is none. So the number 526 is not divisible by 3. Why don't you try one on your own? And once again, there are additional problems at the bottom of page 11 in your SRB. All right, I'd like to continue on. Here we are with the divisibility rules for 5. If a number ends with either 0 or 5, then that number is divisible by 5. So for example, let's start with a nice easy one, the number 25. You see that the last digit ends in 0 or 5. We know that 5 is divisible by 25, so the answer for this one would be yes. Another number would be 315. Once again, you notice that the last number in the digit is 5, so this number is also divisible by 5. Let's check out the number 212. We automatically know that looking at the last digit in the number, or the digit in the ones place, we realize that that number ends in 2, so this number is not divisible by 5. No. Alright? So remember, if a number is divisible by 5 if it ends in either 0 or 5. Our next divisibility rule is 6, for 6. But what's great about 6 is that it combines two rules together. If a number is divisible, so if a number is divisible by both 2 and 3, and that's the key. It's got to be both divisible by 2 and 3. If it's divisible by 2 and 3, then it is automatically divisible by 6. So for example, the number 246. Knowing that the 6 is an even number, you automatically know that it's divisible by 6. And when we looked at the divisibility rule for 3, we know that if you add up all of the digits, 2 plus 4 plus 6, that equals 12, and 12 is divisible by 3. Then you know that because it's an even number and it's divisible by 2, and you know that when you add up all of the digits in the number, it equals a sum that's divisible by 3, and the sum for this one is 12, then we know that 246 is also divisible by 6. So 246 is divisible by 6, yes. So remember, when you're looking at the divisibility rule for 6, it has to be divisible by 2, and it has to be divisible by 3. Remember, the divisibility rule for 2 is if the last digit in the number is even, 0, 2, 4, 6, or 8, then it's automatically divisible by 2. Remember the divisibility rule for 3, if you add up all of the digits in the number and the sum of those digits is divisible by 3, then then that whole number is divisible by 3. And then if the number that you're working with is divisible by both 2 and 3, then it is automatically divisible by 6. That one's a little tricky because it takes two rules. You have to look at another two rules to apply the rule for 6. Now 10, it's really kind of straightforward. If the number ends in 0, then it is automatically divisible by 10. For example, 20, is it divisible by 10? The last digit is a 0, so the answer is yes. 340, the last digit ends in 0, so the answer is yes. So any number that ends with a 0 is divisible by 10. Pretty straightforward. And last but not least is the divisibility rule for 9. It's very similar to 3. So if I had the number, you have to add up all of the numbers or all of the digits in the number. So for all the digits in the number, and if that number or that sum is divisible by 9, then that whole number is divisible by 9. Here's an example. I'm going to use a really large number like 51,372. Once again, you're going to take this number, break it apart. 5 plus 1 plus 3 plus 7 plus 2. You add all these together, that's 6 plus 10 plus 2. This is 16 plus 2 equals 18. Then you have to ask yourself, and I like to use the fact triangle. You put the number 18 here, because that's your sum, and then you have one of the factors already. You're trying to figure out if it's divisible by 9, so you're going to put 9 here. You're trying to figure out if there's a missing factor that will let 18 be divisible by 9. If you know it in your head, you know that it's 9 times 2. So the number 51,372 is divisible by 9. So once the steps again to figure out divisibility for 9, you take the number, add up each of its individual digits. Once you get the sum, put that sum inside a fact triangle, putting it at the top as your total. Use the factor of 9 as one of the factors and try to figure out the missing or mystery factor. If you find there is a factor that goes in evenly, so for in this example, the factor is 2, then you know that 51,372 is divisible by 9. Okay? All right. Once again, you could play this video as many times as you need to, just to make sure that you understand all of the divisibility rules. And if you have any questions, you definitely want to refer back to SRB page number 11. And also look at Math Journal page 14. A lot of the rules have been summarized for you. In addition, if you look at our math board in the classroom, the divisibility rules are also posted in the class. Thanks, and I hope that this is helpful.